Hello, everybody. Good morning. My name is Leonardo Garcia. I'm the chair of the Linaro Data Center Group. We work on various projects, related to data center ARM servers in general, enabling confidential computing with the help of the members, and ARM specifically is one of the main things we have been doing in the past 3 years. The idea for this talk was actually that Matthew was going to present it with a more deep dive in some of the technical aspects that we have been working on since last year. But yeah, unfortunately, he wasn't able to come, so I'm here trying to substitute him and of course giving a much higher level update than he would be able to do. And the good thing is that, talking after Dan, it's easy because he covered half of the things that I need to talk about. We work together, ARM, Linaro, we collaborate, so we have more or less the same roadmap, of course, focusing on with a little different focus, but everything very well aligned. So anyway, so you saw this picture in the previous presentation without this green bar on the left. So CCA covers, the CCA specification, right, covers everything from the hardware up to the service enablement operating system. What we are trying to do at Linaro is a software-focused company, right? So we are trying to make a reference software implementation that people can easily consume, right? And that involves everything from the hardware emulator. In our case, it's QEMU. There is the option of FVP models as well, as Dan mentioned. But the members in the data center group, they usually prefer to use QEMU. So we are enabling QEMU to provide this emulation with RME support. And of course, we work together with ARM and the other members to enable firmware, OS, and everything else that is needed. We are also working on the higher level tools. So we are talking about libvirt, kata containers, confidential containers. Some of our members from Fujitsu, they are also working to enable OpenStack. So there are work happening in many different places. So I think I touched this a little bit. So the project the mission of the project is really to provide this comprehensive set of software and emulated hardware, right? So that includes QEMU, as I mentioned. Of course, all the firmware stack, TF8, TFRMM, EDK2, the majority of these things are being driven by ARM, and we are testing and contributing in the community. Also provide user space components that can support Realm virtual machine. And another big focus for us is to provide the capability to attest the platform. So if you were here in the keynote from Mike Brussel this morning, there was a specific session talking about attestation, right? So that's a concern that we have. Attestation is fundamental in confidential computing, and we are working to make sure that we have standards that can be used not only by the ARM ecosystem, but also by other hardware vendors, and that there are at least reference tools that can be used to do the complete life cycle of the attestation verification capability. So last year, I provided a talk as well at Linaro Connect about what Linaro was planning to do. So this was the future steps slides from last year. As you can see, we completed some of the tasks. So we have cloud hypervisor support. We were able to accomplish an end-to-end demo with Coco doing, not only creating the QEMU emulator, running the host OS, launching the Realm with QEMU as a VMM, running inside this environment, launching containers and doing attestation, all the full cycle. We have this demo. And we integrated Verizon and Coco attestation services as well. So that we can provide attestation solutions within Coco for the CCA token. Some of the other stuff are still ongoing. So we mentioned memory encryption last year. We mentioned SMMU support because that was required for device assignment. And we also mentioned lightweight firmware support. From these three, I mean, memory encryption and QEMU support for SMMU and device assignment in general, these are going fine, I would say. I mean, we are on track to deliver that. The specification is quite advanced. I think it's Alpha 14 or something like that at this point. Anyway, I think we are pretty much on track. Lightweight firmware support, we touched base a little bit on this, but reality is that this is not a hard requirement at this point. We are still in development phase, right? I suppose that when we start to move to production environments, this will become more of a requirement from the members and from the users, especially if you are running containers, but that's not the case yet, or at least we didn't see this as a requirement, a hard requirement from the members yet. So the low-level reference stack, so this covers basically the emulated platform. Since last year, we moved the emulated platform from the QEMU virtual machine type, which was where the RME support was contributed initially, to the QEMU SBSA reference machine type, which tries to mimic, of course, a system-ready compliant system. With this, in theory, anyone that wants to emulate the software or to run all the software stack on a real hardware when it becomes available should be able to run the same software stack on top of this emulated environment. And in theory, again, the results should be the same, right? We also included support for the firmwares for the QEMU SBSA reference machine type. There are some differences between FVP model and this machine type because it's memory mappings and that kind of stuff. So we had to do some modifications. And we also worked on large mappings to support larger memory on hosts. That was a limitation of the QEMU SBSA reference machine type. We included support for QEMU and Cloud Hypervisor as VMMs. KVM2 was done by ARM, as Dan mentioned in his presentation before. And we were also able to test with various distros. So in our build system, and I will point you to a documentation on it in the next slide, we usually use build root as the file system just because it's easier, but we have been running Debian and Ubuntu with success as well, both on the host and on the guest. And I know that some members are even running workloads on top of containers in this emulated environment, right? And these workloads varies from simple stuff to complex AI models. Sure, they have lots of patience to emulate these things, but yeah, they are doing that. We had plans to make public CI available so that we can test and make it easy for anyone in the community to see how things are progressing. Unfortunately, we don't have the workforce yet to do that, but we do have a plan at least. So things are progressing. This is more for reference afterwards if anyone is interested. So we have a documentation that is similar to the documentation that Dan pointed, but instead of teaching you how to build and use the components in the FVP model, our documentation focuses on QEMU. It has steps, to make you to bring you from nothing to running everything from the software stack. I think we are moving to shrink wrap as well. I mean, there was a plan to do that. I'm not sure if we did that already. I suppose we didn't. I'm not seeing Jean here. He was the one. Oh, Jean, we didn't that yet, right? Yeah, it's in progress, yes. So I really hope that at some point in time we will have the same build system as well, and maybe we can have the same images and everything, Probably not together because we're using QEMU and ARM would never publish that, but it would be good to have exactly the same build process as well. As Dan mentioned as well, a good portion of the patches needed for RME are already upstream in the firmware. The only, I think we have one exception for TFRMM, yes, because we have some restrictions in QEMU. I mean, there is a feature that is not being supported in QEMU yet, so we still have a separate repository for TFRMM. But yeah, everything is progressing, and it's quite easy to consume all the pieces these days. On the high-level software stack, so that's the portion that I think it's mainly Linaro contributing in this project. So we had support for Kata containers last year, but it was really initial. Support is much better right now. The Golang runtime with QEMU backend is working fine. We don't have many restrictions on that anymore as we did last year. UEFI boot and direct kernel boot are working as well. Last year, I think it was only direct kernel boot. We can use the Kata deploy tool provided by the community to automatically build the components, right? And it's compatible with some of the branches that we have. So in our documentation, you will see that we mentioned CCAV3, CCAV7, and more recently, CCAV8. So these are just the branches. In case anyone wants to try, the link to the code repo is here. We have instructions as well. It's quite easy to go and try. I will talk a little bit more about what are the next steps on this area as well in the next slides. But so you see that we have things to do yet. Confidential containers, as I mentioned, we integrated support for the CCA token, right, and on Trustee. And we have now local and remote verification integrated with Trustee as well. Right, so one of the challenges that we had in this past year was that we were trying to integrate CCA support in Kata containers, right? And although we have the patches, the community had some pushback because ARM was not properly supported at Kata community at this point in time. So we had to go back and work on the CI enablement, which we did. So it's finished now. We have the runtime Go patches, as I mentioned before, and hopefully the upstream community will accept the CCA patches, the patches to support CCA in the next month or so. Right, Kevin? Hopefully. Kata has some restrictions, so it does not support vCPU hot plug, which is quite important in some of the workloads, especially if you want to speed up the boot time and memory hot plug as well. The problem is that QEMU support is not fully merged upstream for CPU hot plug, so that's a blocker right now. We are working with the QEMU team inside Linaro to fix that. Memory hot plug and unplug, Kata community usually uses the virtual mem interface, so that works quite fine for memory hot plug and unplug. The traditional hot plug works, but unplug is disabled, but that's a problem in the Kata community because usually, when you are unplugging the memory, you need to free the memory before that, and I think, the Kata management system is not really able to coordinate these things at this point, so there is a restriction in the Kata community. It's not really anything specific to ARM or CCA. We also included support for the realm initial measurements in Verizon. So we have a tool that generates DTB for the given machine configuration, and it uses it to calculate the RIM. All right, so talking a little bit more about confidential containers and Trustee, right? There are 4 use cases that we are supporting with the contributions that we made. So the first one is the first one here on the top left, right? You have Verizon services running completely disconnected from the Trustee, from the Coco environment, and you just provide the reference values and you can send the tokens for verification in Verizon. On the right side, at the top, you really have the evidence and the attestation results being shared between the Coco environment and the Verizon services. And recently, we also added the local verification, which means that you don't need to have a Verizon running as a remote service. You can have it integrated into the Trustee, and you can both, manually provision or have the evidence provided to the attestation service. And all these 4 scenarios are working right now. And if you have any questions about that, you can just go talk to Thomas, who is right there, because he understands this much better than I do. As I mentioned before, we have a couple of demos. So we have this end-to-end attestation demo. We have also key broker demo. If you are interested in that, there are links here for you to try them. We are actively working on standards as well, again, together with ARM and other members and other, the community in general. There are folks from universities and from other companies as well. We've been working on the CCA token standardization. There is an ITF draft, if I understand correctly, about this one. The link is there. We have been working inside the Confidential Computing Consortium on the attested TLS work group. This is also a discussion in IETF. There is a draft for that one as well. Usama presented about the attested TLS yesterday. If you were not here and listened to him and you are interested in this topic, you can watch the recording. We have some initial discussions around endorsement API. That was a discussion that started at FOSDEM this year, and we had a workshop the day before, Tuesday this week. We had a workshop around endorsement APIs and standardization. So that's basically, how can you make sure that you have a proper protocol or a standard to distribute endorsement values if you have different vendors. In the case of ARM ecosystem, this is particularly important because you have multiple vendors implementing the ARM IP in the hardware. So we hope that at least inside the ARM ecosystem, everybody agrees to use the same endorsement API. But hopefully other hardware vendors will come as well and join the effort. And we are right now in our device assignment effort writing CCA token extension so that we can expose device assignment measures in the attestation stack. So future steps, we will continue to work on RME 1.1 feature support, right? That's also the main piece of work, I would say, that we have for the next year. Device assignment that are not only the effort in the kernel and the firmware that Dan mentioned, we are working with the QEMU community to add device assignment support. This is an ongoing discussion, in the QEMU community as well. This support is being added not only for ARM, but for other architectures. Memory encryption, we are also working on enabling these. Hopefully, we will have something by mid of this year, at least an initial solution. Planes, I think there is discussion ongoing at the community, although I learned this week that that's probably not exactly what we need. And live firmware activation. So as you can see, very similar to the slides that Dan presented in terms of direction, right? We are working together, so it couldn't be different. On the Kata containers, we plan to enable the Rusty runtime for the QEMU backend. If I understand correctly, new versions of Kata will use the Rusty runtime as the default instead of the Go backend. And we plan to include cloud hypervisor support as well. And of course, continued our work with the standards organizations, right? This is a marathon, right? Not a sprint. I think next slides, I have some, as I have time, I can go through them. It's really just some more details on the new features in RME 1.1. I have one slide that's exactly the same as Dan's, but I will just skip that one. But memory encryption, I think Dan mentioned that well. It's just a way to have different keys for each realm so that you can not only isolate the memory of the realms, but also make sure that if someone eventually accesses that memory, it will be just garbage without the proper keys to decrypt it. Device assignment, that's the same slide. No, planes, yes, of course, planes. Dan touched based on VTPM. That's probably the major use case that people mention. I will add two use cases that I heard from the members. So one was provisioning of the encryption keys of the block devices. Not sure if that is needed with the boot sync stuff that you mentioned, right? Because that probably covers that as well. But usually what the member told me was that today in their machines, this encryption key is provided through the TPM. So if they want to keep the same workflow, they would need the encryption key in the VTPM that would be running plane 0. And the other important use case that I hear lots of times, but I know it's a little bit too early to discuss that, is live migration, right? Probably some support will be needed in plane 0 or in the paravisor to support live migration between different hosts. But I think that's not, I mean, I know it's being discussed and the specification is being discussed internally at ARM, but there's really no timeline for that yet. I mean, it's just early days. No platform supports live migration yet. Device assignment, so yeah, this one is very similar to what I mentioned as well. I don't think I have anything to add really on device assignment. Dan explained very well all the use cases and everything that is needed. I would just highlight that, you know, when you have a device assigned to a realm, we need to make sure that if anything changes in the device needs to be blocked from, I mean, it needs to be deactivated basically, right? So the device assignment, the TDS protocol, it provides support for that kind of feature. But of course, you know, there is lots of work to go probably in the VMM to make sure that, you know, this is constantly checked, and if anything changes, the device needs to be reset. And live firmware activation, I really think this is a funny, very interesting feature. You know, this use case is changing the RMM image before booting the machine. The use case is the use case that I really like most about live firmware activation is this one, which is, imagine that you are running the realms and you need to update your firmware, but you don't want to shut down your realms, right? So this will probably, hopefully, be possible with live firmware activation. And for the ones that don't know, I mean, I've been working with virtualization for a long time before joining Linaro, and this was like the ultimate goal of anyone running VMs. They would like to be able to update the host or the VMM or the firmware, but they didn't want to stop their VMs, and eventually they didn't even want to live migrate them to somewhere else, right? So yeah, I'm really excited about this kind of feature because I think it really adds value to end customers. And that's it, I think. Oh no, yes, of course. That's more for reference as well. I mean, this is the roadmap for the next year for the CCA enablement project inside Linaro. You can see, I mean, it's basically what I mentioned before, right? So there's a bunch of work on Kata to make sure that we enable CCA support upstream, work to enable the RME 1.1 features. So yeah, not exactly what I mentioned, but there is a timeline there that you can follow. This is public, so we keep updating these. If anyone is interested, I can send the link of the live document. And now, yes, thank you very much. Any questions? We have 1 minute. Now it's some seconds. Thank you very much, Dan. If you have any other questions, you can just catch me up outside.